All right, here's a little video on logarithms. So again, this was told to me the log is equal to the exponent, and it was told to me to keep that in mind when you're working through these. So our general equation is going to be y is equal to log of the base x. Okay. And in this equation, what this is telling me, or another way of looking at this, is going to be that I can take the base to the exponent of y has to be equal to the value of x. Okay, so that's another way of looking at it. And I'm going to run through two examples here. So example number one here, I'm looking for the value of y when I have a log of a base 10 and x is 100. So what would the value of y be? Well, again, I'm going to take 10. I'm going to take that base of 10 to the y power, and it has to equal 100. So that means that y is going to have to equal 2. So 10 to the second power is going to be 100. So going back, let me erase this because that 100 came out looking really weird. So again, so my value for y here was 2. Example number 2. What would the value of y be if I have a log base 10 and this time the value of x is 0.01? So let's take a look at this problem here. Again, that base is 10. I need to raise it to the power of y to equal 0.01. And that's a really funky looking y there. In this case, 10 is going to be a negative 2. So 10 to the negative 2 is going to give me 0.01. Okay, and I can check that because that one's a little bit harder to see than the last problem that we did. But here I would get 1 divided by, and if I do 10 squared is going to give me 100. So 1 divided by 100 gives me 0.01. So those are two examples there that we can use to understand what this log equation is telling me. Okay. So how does that translate into acids and bases? Well, for an acid and a base, the Y is going to be the pH value. And sometimes, as I have it down here written in blue, it can be the pOH. So that's my value for Y. My X, my value for X is going to be the concentration of either the hydrogen ion or the concentration of the hydroxide ion. And the value for B is going to be 10. Okay, for both equations. Now, why am I using 10 here? The reason I'm using 10 is for a specific reason, because the pH scale that we use to identify acids and bases is based off of 10, right? So the B is going to be 10 on the pH scale. So that's why we use B here is equal to 10. So if we put this all together, we get the equation pH is equal to the log of the hydrogen ion concentration. Now, why do we see a negative in the equation? So down here in blue, I have these two negative signs. Where does that come from? Well, since the molar concentration of the hydrogen ion or the hydrogen in aqueous solutions is very, very small, and an example here I have is 1 times 10 to the negative 7. If I were to take a log of this number, it would be negative. So to make it a positive number, because we have to have it a positive number so we can compare that to the pH scale. All those numbers on the pH scale are positive numbers for us. To make it a positive number so that it can fit that pH scale, it's multiplied by a negative 1. So to keep the equation simple, we just drop the 1 and we leave the negative sign. So the final equation is pH is equal to the negative log of the hydrogen ion concentration, or pOH is equal to the negative log of the hydroxide concentration. Now, one other thing I will talk to you about here is that you'll notice that in my original equation, I had that b that was in there where I had y is equal to the log of the base 10 and then the value for x. You'll notice down here on the equations on the bottom, I don't have that 10. I don't place that 10 in there. And the reason for that is because, again, we already know that it's a base 10. That's what the pH scale is based on. We're not going to change it. So again, it's left out just to make the equations a little bit simpler. So this was our lesson on logarithms and how they relate to acids and bases and where those two equations came from.